All right, we're going to take a look at linear regressions, mainly how do we use a table of information to create a line of best fit, and then also how do we use that to make predictions, and we're also going to look a little at causation and association. So we need to first remember that linear data has three types of correlation. So correlation is kind of showing your trend. It's showing the kind of pattern to it. It can have a positive correlation. So a positive correlation means that when you have a scatter plot, your dots are trending in an upwards direction. So they're slowly going up and to the right. Now, it may not always be going up, but for the most part, you can kind of see that pattern. You can see it moving up. A negative correlation is the opposite. It is when your scatter plot is trending in a downwards direction. So it is trending down and to the right. Okay. And then no correlation is when they're just all over the place. Okay. It's not going up or down. You can't really see it. It's just kind of everywhere on your graph. All right. There's no clear going up or going down. So those are the three types of correlation they're going to ask you about with linear data, is positive, negative, or no correlation. So a linear regression model is a line of best fit that can be used to represent the overall trend of the data that mostly has a linear relationship. So back in 8th grade math, you practice doing a line of best fit when they give you a scatter plot and you have to get a ruler and your pencil and actually draw a line that shows where the trend is heading. In Algebra 1, we get to use technology to make a more exact line of best fit, which is why it's called a linear regression, because we're using the strategy of regression in that calculator model to find an exact line. The correlation coefficient is something that goes along with that model. It tells us how well the model fits the data. And so we need to remember this because they're going to ask you EOC questions. It says a perfect fit is when R equals 1 or R equals -1. So when R equals 1, that means that you have a positive correlation. Okay, so your R is going to equal a positive number. When R equals -1, that's because you had a negative correlation. When R equals just 0, that's a no correlation. There was no pattern to it. So if we think about our correlation as a number line, we can't go any further than 1 or -1. Those are our perfects, okay? So -1 is a perfect negative, and +1 is a perfect positive fit. Okay, so what this means on a graph is if I had my scatter plot, the line I drew was able to go through every single point, whether my points were heading up or heading down. All right, that's what it means by a perfect fit. It went through every point. Now, if I have 0, like I said earlier, this is no correlation. This means that my dots were all over the place. I couldn't find a line to represent what my data was doing. And then anything in between there is varying on strengths of weak to strong. So strong is going to be the closer you get to 1 or -1. So typically we call strong anything from 0.8 and up, or -0.8 if we're heading in the other direction. That's usually a pretty strong fit. All right, so 0.8, 0.9, stuff like that. Weak is the closer you get to 0. Okay, definitely I would say anything under 0.5 is a weak correlation. Okay, so anything below 0.5 would be a weak correlation. Anything above 0.8 is a strong correlation. In between those is just kind of the They usually ask us about correlations that are really strong, like clearly strong, or they ask us about really weak correlations, okay? All right, So great thing now is that we get this tool called Desmos on our EOCs, okay? Desmos makes finding our linear regression model, our linear regression equation, super easy. All we have to do is we have to type in our table on Desmos and then click a button and it will tell us what the equation is, versus with the calculators where you have to remember a whole set of steps in order to find that. So when we're using Desmos, what we're gonna do is we're going to click the plus sign and then you're gonna click the table icon, all right? And then that's gonna let you to type in your table values from your problem. And then once you have that typed in, to the left of the table, you're gonna see something that looks like a line surrounded by dots, all right? It'll look like this. Okay, we're gonna click that button. And that tells it that we want a linear regression. And so when we do that, when we click that button, something will pop up that looks like this. Now this is just from an example that I did. We're gonna get a different equation, but that's what's gonna pop up on your screen. Now when this pops up, this right here, the y equals, let's make sure we circle or highlight that. That is your linear regression. All right, and we could say model or equation, whichever. Those words are interchangeable, but that's the linear regression. And then another important piece of information we need is this lowercase r. That right there is your correlation coefficient. That tells you how well your line fit your data. Okay, so you can see this one had a strong fit. It was 0.9933, so it was almost perfect. So we would call that a strong positive, because it was a positive value, a strong positive correlation. All right, so let's try this out with this example here. We've got this table. We need to put this in Desmos. Oh, my pen died. Okay, I'm going to put that in Desmos because it's going to ask me what is the linear regression model. And then notice also in my instructions, it says round to the nearest hundredth. So nearest hundredth means we're going to keep the first two numbers after the decimal. And then whatever the third number is, that tells the second number if it needs to round up or down, okay? If that third number is 5 or higher, the second number needs to go up. If that third number is below 5, we keep the second number like it is. Okay, let's see if I can do half screen here. And Desmos. Okay, all right, so I'm gonna type in this table. I'm pushing my plus sign. I'm clicking table. And then I'm gonna type in what I've got. So I had 2 for my x. Why is my board not working? There we go. All right, 2 for my x, 8 for y. Go down, I had 4, and then 13, 5, and 9, 7, and 14, 9, and 20. Okay, so you want to go through and make sure you double check your table and that everything was typed in correctly, because if you give it the wrong information, it's going to give you the wrong information. And so you can see it's already started to graph my little scatter plot. So I can see my dots are heading up and to the right. This has a positive correlation. Now I just need to see what line would best describe their pattern, would best describe where they're heading. And so you can see right beside my table to the left, there's a little symbol with a line with a bunch of dots. I'm going to click that, and then boom, it popped up with my linear regression. And so what I'm going to do is I'm going to copy that onto my note. All right, so my linear regression model, that's the equation. So the equation was y equals 1.55. The next number was a 4, so that means I'm going to stay at 55. And then I'm going to put x plus 4.40. The next number is a 4, so that means I'm going to keep the 0 like it is. So that's my equation rounded to the nearest hundredth. Next one says, what is the correlation coefficient? So remember, that's the lowercase r. So looking at the lowercase r, it says r equals 0.88. My next number is a 1, so I'm going to keep that as 88. So looking at that, 0.88, that's positive, right? Because we saw our dots and our lines going up and to the right. And then that's pretty close to 1. Okay, so that is a strong positive correlation, if they ask me what type of correlation it is. All right, now next it says when x equals 30, what will be the value of y? And so we're using our regression model, and we're going to figure out what happens when x is 30. So my regression model was y equals 1.55, and then instead of an x, I'm going to put a 30 there, and then plus 4.40. And then I can even use Desmos as my calculator to type this. I'm just going to go to my next line. And let's see what happens when I type y equals. Let's see, y equals 1.55 parentheses 30, and then plus 4.40. Okay, and see, look, underneath it, it says equals 50.9. So that is our answer, y equals 50.9. All right, now on the next one, it says when y equals 10, what will be the value of x? So this time we're replacing the y with a 10, and we're keeping x as an x. My buttons, x plus 4.40. So let's see what Desmos says. Let's see if we can do this on Desmos. All right, we may not be able to. 10 equals 1.55x plus 4.40. No, it just made a random blue line on my graph, okay? So what I'm gonna do is I am going to need to solve this. This is an equation I need to solve. I'm gonna get rid of this so I have more room, maybe. There we go. All right. So to solve for x, remember we wanna get x by itself. So my first step is going to be to subtract 4.4 from each side. And so when I do that, that gives me, with my pen not working, there we go, 5.6 equals 1.55x. And then my next step is to divide both sides by 1.55. Okay, that'll give me an x on my right side, and then 5.6 divided by 1.55. We had a long decimal, and we are still rounding to the nearest hundredth, so that's going to be 3.61. The next number was a 2, so I'm going to keep the 1 like it is. And so the answer for this is x equals 3.61. All right, last bit is talking about association and causation. You've done this before in English class. Whenever you hear the word causation, you've got to think cause and effect. All right, so causation is cause and effect. So if it's not a cause and effect relationship, it is not causation. It is probably association. And so what that means is in math, when we're talking about causation, we're asking, does the changing one variable, changing one thing, does it affect the other thing? Okay, does it cause the other variable to change? If it does, that's causation. Now, if it's association, changing one variable may look like it's making the other variable change, but that's just because they're associated through a third party, okay? And it's actually a third variable that's controlling things. So let's look at example 2. It says, which situation shows causation? So we're looking for a cause and effect relationship. So A says, when the number of ice cream cones sold increases, the number of shark bites increases. Does selling ice cream cause sharks to bite you? The answer is no. All right, this is not causation. This is association. And so if we looked at data in the summers, we would probably see that ice cream is being sold more at the beach and shark bites are happening more often at the beach. But think about why. It's because more people are going to the beach at that time because it's hotter weather. It's the summer, right? They're eating ice cream to cool off and they're getting in the water to cool off, which causes an increased chance for shark bites. So one is not causing the other. They're both being caused by the time of year and the amount of people going to the beach. On B, it says the more questions you get right on a test, the higher the grade will be. That is correct, right? The better you do on the test, the higher your grade's going to be. So this right here is a causation. This is a cause and effect. The number of questions you get right is causing your grade to increase. And so B is the one that shows causation.